Ever wondered why spaceships don't freeze in the icy cold of space? The temperature of space is not a simple concept, as it varies widely depending on the location and conditions. Generally, the temperature in the vast empty regions of space can be as low as 2.7 Kelvin, 270.45 degrees Celsius, or minus 454.81 degrees Fahrenheit, which is the temperature of the cosmic microwave background radiation left over from the Big Bang. However, spacecraft do not get frozen for several reasons. 1. Thermal control systems. Spacecraft are equipped with sophisticated thermal control systems designed to manage extreme temperatures. These systems include insulation, heaters, radiators, and thermal blankets that help regulate the internal temperature of the spacecraft and its instruments. Passive thermal control methods like multi-layer insulation, MLI, reflect and minimize the absorption of solar radiation. Active thermal control involves heaters and heat pipes to distribute and dissipate heat as needed. 2. Solar radiation. In many parts of space, particularly within our solar system, the sun provides a constant source of heat. Spacecraft absorb solar radiation, which helps maintain a temperature that prevents freezing. For example, the International Space Station, ISS, is in constant sunlight for about 45 minutes of each 90-minute orbit, providing ample heating. The spacecraft's orientation and position relative to the sun are managed to balance the heating and cooling effects. 3. Radiative cooling. Spacecraft primarily lose heat through radiative cooling, emitting infrared radiation into space. This process is slower than convective cooling, which doesn't occur in the vacuum of space, allowing spacecraft to retain heat longer. Designers ensure that spacecraft have surfaces and materials that emit the right amount of heat to maintain temperature balance without excessive cooling. 4. Internal heat sources. Many spacecraft have internal components that generate heat, such as electronic equipment, computers, and life support systems, in manned spacecraft. This internal heat production helps maintain a suitable temperature inside the spacecraft. In manned missions, the presence of astronauts also contributes to the internal heat load, as the human body generates heat. 5. Environmental factors. The specific environment where the spacecraft operates affects its temperature. For instance, a spacecraft orbiting close to a planet might experience reflected sunlight or planetary thermal emissions, influencing its thermal state. Spacecraft traveling through different regions of space encounter varying conditions, from the warmth of the inner solar system to the cold of interplanetary space. In conclusion, spacecraft are carefully designed with thermal management systems to ensure they do not get frozen, despite the extremely cold temperatures of space. These systems balance the absorption of solar radiation, internal heat generation, and radiative cooling to maintain a stable temperature suitable for their operation, and the safety of any crew on board.